Welcome to BKW. My name is Mr. McConnelly. We're going to talk about forces today. And in its most general sense, a force is a push or a pull. That's something you probably learned in middle school science. That was the definition. But we're going to get a little more specific this year, and this is your first introduction to the different types of forces. Now, usually physicists break it into four fundamental forces that encompass all the different pushes or pulls that you can have in the known universe. And these are labeled this way: strong, electromagnetic, weak, and gravitational. Now, I put them in this order for a reason, because in terms of strength, this would be the strongest. And over here would be the weakest. Now, the only reason that confuses anybody, because, if I just tell you the order, it's no big deal there, but why it confuses people is because they think weak should be the weakest force. It would seem to make sense, but it's not like that. This is the actual order: strong, electromagnetic, weak, gravitational. Okay, so let's talk about what each one is. Start with gravitational, because it's the one you're probably most familiar with. Gravitational attracts things with mass. So, if you have mass and something else has mass, the two things will be attracted to each other. A simple example: the moon being attracted to the Earth. The moon keeps going around the Earth because of the gravitational force. Things with mass attract it. Now, we'll get much more detail this year. We'll learn that two people sitting next to each other in the classroom are actually attracted to each other also, because you both have mass. You're actually being attracted to each other in a non-creepy way. All right. The next one I'll talk about, I'll just go from right to left, is the weak force. And the weak is by far the most nebulous of the forces, and it's hard to wrap your mind around. But you guys know about radioactive decay from chemistry. And when you have radioactive decay, you are emitting particles from the nucleus. You know that. And when you're emitting particles from the nucleus, that implies that something must be pushing them away. That's the weak force. Okay? So it's the force that emits these particles. Alright? So you got the weak force. It has to do with radioactive decay. Emitting particles from the nucleus. I guess I'll add during decay. Make that a little bit clearer here. So it's the force that emits these particles. Electromagnetic force, that's an easy one. That's anything with charge. So you know that two things can be attracted because opposite charges attract. You learned that a long time ago. And you know that things can be repelled if they're the same. So if you got two negatives, they're going to push apart from each other. So electromagnetic force is anything with charge. And the last one, the strong force, is one that some people know a lot about, other people don't. It's also called the nuclear force. And basically, it holds things in the nucleus. So what's in the nucleus? What are the main things in the nucleus that you know about?
Protons.
Protons and
neutrons.
Neutrons. Why would those things actually be held together? Because remember, protons are both positives, and that would indicate, because of the electromagnetic force, that they should actually push apart. But they don't. And in fact, they're very strongly held in there. And there's also neutrons in there which have no charge, but they're very strongly held. In fact, if you crack the nucleus in half, what do you get?
A bomb.
Like an atomic bomb, yeah. So they're very strongly held together, but yet when you think about it, they really shouldn't be. That's the strong force. And UKW Physics.